working. We're going to be working with Chapter 12 again, and we're going to do the last half of Chapter 12. The first half was dealing with future values of ordinary annuity and annuity due. And remember, when we were working with future values, the ordinary annuity is when the payment is made at the end of the payment period, and the annuity due is paid at the beginning of the pay period. So we can make more money if we can have an annuity due. So to calculate present value, we're going to be working with the same steps that we did for the present value, for future value. Calculate the interest rate per period for the annuity, which is the nominal or annual rate, divided by the periods per year. Determine the number of periods of the annuity, years time periods per year. We're going to be working with Table 2, the present value table. And we're going to look for the intersection of where our steps 1 and 2, our rate and our periods, will intersect. And then we'll calculate the present value of the ordinary annuity by taking that factor times the annuity payment. So find your Table 12.2, and we're going to work a problem together. I have a Table 12.2 here, but it only goes through years 20. The one in the textbook will have more years to it. Having trouble getting the computer to manipulate where I want to go. Okay, we're going to figure a present value of an ordinary annuity. A theater wants $20,000 available at the end of each 6-month theater season for renovations, a new stage, and lighting equipment. How much must be deposited now at 8% compounded semi-annually to yield this annuity payment for 6 years? So use your steps that we just went over, and I want you to figure what you will have for your payment. You can pause the presentation at this time to do that. Your interest per period, it was 8%, it was semi-annually, so that's twice a year, so it would be 4% for each of the pay periods. We have 6 years, and it's twice a year, so it would be a total of 12 payment periods. So we would look for the factor 4%, 12 periods, and you'd have 9.38507 present value table times the payment, $20,000 that we want, or the amount that we want in 6 years. So we would have $187,701.40 in that 6-year period by making that $20,000 payment. Okay, next we're going to look at, you can look at page 383 and example 4. You can pause this again and look at that example. We're going to look at figuring present value of an annuity due when the payment's at the beginning of the period. We will still need to, I don't know why they swapped the steps here, because it would be, step 1 would be to calculate the interest rates to be consistent. And then step 2, we calculate the number of periods of the annuity, and we subtract 1 period because we have to adjust the present value table, just like we did when we were working with the future value and doing an annuity due. once we have these numbers, we can go to 12.2, and again we look for the intersection of the steps 1 and 2, the periods and the percentage rate. And we'll be adding one, again, this is to adjust the table from ordinary annuity table to annuity due factor. And then we calculate, this should be, it has future value, but it should be present value. Present value of annuity due is annuity due table factor times the annuity payment. So let's work a problem together. Based on sales and revenues expense for forecasts, it is estimated that $10,000 must be sent to the IRS for income tax purposes at the beginning of each 3-month period for the next 3 years. How much must be deposited now at 6% compounded quarterly to yield the annuity payment needed? So use your steps that we went over, pause the presentation, and figure your answer. We would not need to find the interest per period, so it would be 6% divided by 4, 1.5, and then it's for 3 years, and it's 4 quarters, so that would be 12, but we need to subtract 1, so it would be 11 payment periods. We would go to the table 12.2 and find 1.5% and where 11 payments intersect. It'd be 10.07112, and we add 1, so our factor is going to be 11.07112, and we'd multiply that times our 10,000, and so we would need we would have $110,711.20. That we would need in 3 years. You can go to page 384 to example 5 and pause the presentation. The next part of Chapter 12 deals with a sinking fund. A sinking fund is when the future value of an annuity is known and the payment required each period to amount to that future value is unknown. Sinking fund are accounts used to set aside equally amounts of money at the end of each period at compounded interest for the purpose of saving for a future obligation. Businesses use sinking funds to accumulate money for such things as new equipment, facility expansion, and other expensive items needed in the future. Another common use is to retire financial obligations such as bond issues that come due at a future date. Individuals can use sinking funds to save for college education, a car, the down payment on a house, or a vacation. So this is something that you can personally use. You're going to use the appropriate rate per period and the number of periods for the sinking fund to find the future value. So we're going to be using table 1. And after you find that factor, then you're going to take the future value of the sinking fund and divide it by the table factor. So let's work a problem together. Steve wants to accumulate $8,000 in 5 years. If his bank is paying 12% interest compounded quarterly, we don't see those kind of interest anymore, so it's sort of hard to get the money that you need in future values when you have interest rates as low as we have these days. But it's compounded quarterly, and how much must he deposit at the end of each 3-month period to reach his desired goal. So if it's at the end, then that means that it's like ordinary. So use your steps that we just went over to figure the sinking fund payment. Is 12% interest compounded quarterly, so 4 into 12 is 3% per period. The number of periods is 5 years, 4 quarters for each year, so it's 20 payments. So we find the factor. And we take the future value of the sinking fund, which we're trying to accumulate $8,000, and divide it by the factor, 26.87037. So $297.73 is how much we would need to make 4 times a year for 5 years to get $8,000. Let's move to amortization. If you have a mortgage, a car payment, you probably have seen amortization booklets or a whole sheet that they give you so you know what your payment is, when it's due, and how much you paid in interest and what the balance is. To calculate an amortization payment, again, we will find the rate per period and the number of periods of amortization and find the present value. So it's 12.2, table 12.2 that we'll be using. And then you calculate the amount of the amortization payment. Amortization is the opposite of a sinking fund. Amortization is a financial arrangement whereby a lump sum obligation is incurred at compound interest now, which is present value, and paid off or liquidated by a series of equal periodic payments for a specified amount of time. With amortization, the amount of the loan or obligation is given, and the equal payments that will amortize or pay off the obligation must be calculated. And some businesses will use of amortization to pay off loans, liquidating insurance, or retirement funds. So let's use this. A fisherman purchases a new fishing boat for $130,000. He made a $20,000 down payment and financed the balance at his bank for 7 years. What amortization payments are required every 3 months at 6% interest to pay off the boat loan? So pause the presentation and figure your answer. The interest per period is every 3 months, so it would be quarterly. So 16% divided by 4 is 4%. There's 4 periods times 7, so we have 28 payment periods. And this should say amortization fund payment is the original amount of the obligation divided by the present value factor. So the original amount of the obligation is $130,000 minus the $20,000. So what has been loaned is $110,000. And then you divide that by the factor that you found, 16.66306, and it totals $6,601.43 is a fund payment. This is the same example that is also in the textbook. These are sections that we are skipping, but I have given that also in Blackboard. And this moves us to review problems for this chapter 12. So Jill has saved $200,000 and she wants to amortize, so we know it's an amortization problem, that amounts in a retirement fund so that she will receive equally annual payments over the next 25 years. At the end of the 25 years, there will be no funds left in the account. If the fund earns 12% interest, how much will Jill receive each year? So pause the presentation, use your amortization steps, and you will be using the future value table. Since she will receive payments annually, it's one time a year, her interest rate per period is 12%. The number of pay periods is 25. She's getting paid one time for each of the 25 years. We find the table factor is 7.84314, and so we would take the amortization original amount, and it was $200,000, and divide it by our factor to get $25,499.99 she would get each year for 25 years, and that would liquidate the $200,000 retirement fund. Our next problem: a bank is paying 6% interest compounded monthly. Find the future value of $100 deposited at the end of each month will be worth after 2 years. So if it's at the end of each month, then we know this is an ordinary annuity, and it's going to be the future value, so you want to use the future value table. So go back in your book if you need to look up finding an ordinary annuity. It's monthly, and it's 2 years, so it'd be a total of 24 months, 24 pay periods. They got these out of order. Normally you do our interest first. It's 6%, and it's being paid 12 times during a year, so it's 0.5%. You find where the 0.5% and 24 intersect, and we come up with 25.43196 times our $100 payment, $2,543.20. Here's what it will grow to. Our last one is calculate the amount of the periodic payment needed to amount to $50,000 in 8 years, compounded semi-annually at 10% interest. So this is like a sinking fund, because we want $50,000 in 8 years, semi-annually, 10%. So we need to find out what is our rate. 10% divided by 2, 5%. Number of periods, 8 times 2 would be 16. We find our factor value of the sinking fund, which would be $50,000. And this 2.365749, our factor should be underneath the 50,000, so our division. And we would need $2,113.50 to grow to 50,000. So that concludes Chapter 12.